on simulation. Right, so why have simulations in trusted autonomous systems? Well, first of all, any kind of evaluation, if you do that evaluation in the real world, let's say with a self-driving car, that could be very dangerous. Also, you can't cover a very wide range of situations. So each one is quite expensive to set up, and doing lots of them would be extremely time consuming. But with a simulation, one can set it up to do huge numbers of environmental situations and evaluations of those situations. And in particular, you can then identify rare events which you might otherwise miss. And this is a standard modern industrial practice. So I think it's something we should definitely be doing. Of course, that doesn't mean that we don't ultimately want some evaluation in the real world, but certainly in the early development, it's very useful to have simulations. The simulations can model both the agent who's supposed to be autonomous and the environment that they work in. And of course, there may be multiple agents. We can describe the model using natural language, photographs, maps, formulae, etc. Rather as Alex Laskaridis was talking about this morning, how she is extracting models of the environment and the agent from these kind of inputs. Combining formal analysis and simulation it has advantages because they're complementary. The formal reasoning can provide explainable causal traces for accidents and corner cases, the kind of thing I think it was it Lachlan was asking for earlier in terms of whether simulations could provide the sort of legal basis for legal arguments. So formal reasoning, I think, can help there with a more deductive explanation of what happened. But the simulations can provide evidence and illustration of that formal analysis. Stuart was saying to me that Waymo are using simulations to provide lots of examples that are then used by a machine learning system to learn. I have mixed feelings about that. I mean, it can provide huge amounts of evidence, but evidence coming from simulation is not quite the same as evidence coming from the real world. So I'm worried that you might be misled in that way. Could be that biases built into the simulation are then affecting the machine learning system. You can incorporate specifications and constraints and so on into the simulation, and then look for the effects of those. So, for instance, if you're planning on certain kinds of legal constraints, for instance, you could try out different ones and see how that then works in the simulated environment. It enables us then to evaluate algorithms and constraints within the simulation and see what effect they have. And you can explore corner cases and counterexamples and so on. So one of the major things then is using the simulation to throw up rare events which in which complex environmental combinations can create difficult corner cases, can throw up counterexamples which you then have to go and deal with in your model, in your algorithm, for instance. We in P3 have been looking at self-driving cars, whereas we said that we would look at drones, UAVs, but we see that as a pathway. The self-driving, as Andrew was saying this morning, the self-driving cars, there's a lot of existing regulations and highway codes and so on, and lots of examples of self-driving cars being built, which we can then use to explore and learn lessons which could then be applied to UAVs. Now, the one of the simulations that we're using is this CALA system. Car Learning to Act is what it stands for, and it provides a model of a car or cars in an environment, and then can simulate the autonomous driving systems. You can set, it can model both static things like the houses and trees and so on, and also dynamic objects like the car here. You can set up various environmental conditions to look at. So this one here, it's raining, and this one here, the sun's shining, and here it's getting dark, and so on. It can suggest missing key environmental variables. So this one shows a situation in which you're blinded by the sun, and then you may not have thought of that in the model. So that would then suggest having rules for dealing with that kind of situation. And it allows an interaction then between the agent and the environment, which you can explore different options, different situations. This CALA supports various standards like the Open Drive High Definition Map Standard and the Scenic Scenario Description Language, which is a formalism for describing rules and so on. So I was asked to do this in conjunction with Pillar 2, and Hannah raised various issues that they've been discussing in Pillar 2, which might then form a basis for our further discussion. So in Pillar 2, they're much more interested in the healthcare domain than self-driving cars. So what simulations do we have in the healthcare domain? How can
just maybe so Alan, just to expand.
Do you want to take us? Do you want to take us?
No. I just
I'll just
add based on our.
Yeah, sure. Tip in.
So, for example, one of the questions is, are clinical trials simulations, right? So they're probably not, because they are still performed on real people. On the other hand, this is probably as close as we can get in the healthcare domain to simulations, right? Because this is what we need to do in order to gauge the efficiency of treatments. Or for example, are the trials on animals simulations, right? So all this, what is the parallel of simulation in the healthcare domain?
Well, you can imagine modeling not just the patient, but also the surgeon, for instance, in an operation, and then trying to program the surgeon to deal in general with this kind of problem, and then varying the patient's situation to see, if you could come up with circumstances in which current advice to surgeons doesn't apply, and explore unlikely combinations of situations.
Right. Yeah, it's possible. So, and then about explanation, since we are very interested in explanations in Pillar 2. So how can we use simulations to contribute to explanations, right? Because as I think we started the discussion earlier today, that explanations are very challenging, and especially when we're trying to move from explanations of a single input to explanations of multiple input, of a class of inputs, it becomes even harder. And maybe we can use simulations to contribute to explanations. For example, when we're asking whether particular parts, particular features of input have a significant effect on the output, or they should be part of the explanation. Maybe we can run simulations to judge or to estimate the measure of efficiency. And in fact, when we're looking at explanations of image classifications, this is in some sense what we're doing exactly, because all the explanation techniques so far, they modify the image in some way and then they rerun it to see what's happening. So there we can probably talk about it being some type of explanation.
Yeah.
Some type of simulation, sorry.
Yeah, you need to have some way of abstracting from the particular thing that's been modeled within the simulation to remove the irrelevant detail and the focus on the big picture of what's gone on. Thinking about this, we haven't actually looked at machine learning in P3 yet. We've been modeling at a higher level of traffic regulations and so on. But self-driving cars use machine learning for things like image recognition, and we're obviously going to have to look at that. And there's a nice example recently. I don't know if you follow this, but Tesla cars were crashing into stationary emergency vehicles. And this was very strange because, normally this would be very visible. And it turned out that the ability of the car to recognize another vehicle was predicated on it actually moving. So it just didn't recognize stationary objects.
This is quite a catastrophe, right? I mean, because
that's a terrible flaw. I'm surprised Tesla cars are allowed on the road anymore after that.
So is this confirmed by Tesla?
Ram may know more, but that's what I read in really? Press articles about
because
it.
There can be many guesses to the reason. So, for example, there was this incident when Tesla crashed into the overturned lorry, right? And the lorry was a very big one and white. So the guess was that it just saw a big white rectangle, assuming that there is nothing there. But maybe it was that floor back then, right? Because the lorry didn't move. But there was no explanation or justification from Tesla. So
extracting that high level abstract explanation from the detail of the simulation, I think is a real challenge. So
I agree. And just just as a side note about Tesla, it's a real challenge to explain why there is nothing there. So because in case Tesla wants to continue moving, it can move only when there are no obstacles. And the brute force approach of naming the obstacles won't work because obviously, there's some misclassified objects, or there can be some unexpected objects, right? If there's, a giraffe suddenly walking across the motorway, you want to be able to recognize it as an obstacle, even though it's not on the list of things likely to block your way on the motorway.
Of course,
there's a challenge there, right? With
the simulation, you can do experiments as well, of course. So if you think a certain explanation is true, you can try a situation which varies from that and see if the problem still arises to test your hypothesis. So and you can do that without killing people, which is obviously an advantage. It's not the experiment you could do perhaps in the regular world, in the real world. So you raised this about what exactly is we going to simulate, and I assume what you're referring to here as a black box AI is some machine learning system in which there's a challenge about explainability. So you actually difficult to know. I mean, you can know at some very low level of detail what's happening with a neural net, what the weights are, and which nodes fire and which ones don't, and so on. But that's completely unhelpful.
Exactly, and maybe even irrelevant, right? Because absolutely.
Yeah.
So what are we simulating? So we're kind of guessing or thinking in the direction of simulating the whole interaction, where we will rather simulate the real world interaction with the black box AI by using black box AI for the simulated inputs. But we will invoke this real, network, because simulating the network, I think it takes us into a wrong direction. We're not interested in that, right? We're not interested in looking inside the network and seeing the particular interactions between the layers.
But we can do experiments, so we can set up a slightly different situation and see if the problem repeats or not. So, if it were a moving fire engine,
with the same AI, right?
Or if the object was more readily identified as a turned over lorry or something. So
yeah.
Okay. And then another question you asked was how simulations account for the uncertainty in the operating environment. So
that was raised actually not by me, but by people who are looking at uncertainty. I think it was June mostly who was looking at uncertainty, maybe even a little bit Bargavi a little bit as well. So if they want to take this one and to expand on it more.
Yeah, I think it's a similar situation to the one we just described, because one of the problems here is that the simulation is a kind of concrete case. You can't build uncertainty into the model. You can't. You have to put the car in a particular position. You can't say, well, it's somewhere on this road, but I'm not sure exactly where. It seems to me there you're going to have to try many different situations and see, which of them result in what kind of outcome. So, if you're dealing with this overtaking problem that Alice was talking about this morning, the position of the oncoming car is extremely important. So you could try it out various situations and see when you hit the oncoming car and when you don't. So
yeah, absolutely.
And
but also
that way.
there's probably too much uncertainty, right, to cover all of the possibilities in simulation.
Yes.
So we kind of have to rank the uncertainty according to its importance. I see that Shin wants to.
Yes. Sorry.
Yeah, Shin, please go ahead. Yeah.
Yeah. Hello. Yeah. So from my side, the simulations account for uncertainty mainly exist because we have limited test data and test environments. So if you would like to know how would the model react or perform in different kinds of environments to estimate the uncertainty, then we need to do simulations to generate more test data or to simulate more test environments so that we can have a more accurate estimation for the uncertainty of the performance of the models.
Mm-hmm. Okay, I see we've got quite a lot of questions in the chat. So let me see if there's any more bullets here, and then no, that was it. So maybe we should. I can stop sharing and. Oh, that's no good. So I've got all your pictures obscuring where the button is. Yeah. Okay, so we have a look at these points in the. I'm not sure how far back we have to go.
I think we're starting
Okay,
from 1504.
I think Peter Davis is the first one. Carla is truly inadequate in any remotely adversarial situation. How do you look at attacks against ML on sensors? How do you look at bus timing errors? How do you look at quantization errors? We've done work using supercomputers, etc., and integrated physical components. Your big question for any simulator is how it breaks down when it hits the combinatorial explosion associated with physics. Anybody? I don't have any personal experience with Carla, but
well, I was curious about the comment about how it wouldn't work at all with adversarial attacks on ML sensors.
Mm-hmm.
And a lot of these simulations, you have access to replications of the depth sensors, the LiDAR sensors. You can introduce noise. You can take the image, and before it hits the car decision-making system, you can add in adversarial noise. You can add your custom models to the environment. So I guess I was curious what your thoughts on that
in there, because on simulation, so the first thing, observation on the simulation, is when you hit the physics. I think the study they did down at Bristol showed that anywhere you went above about 2% resource utilization, you didn't get deterministic outcomes. So it's not I don't like Carla, I use it a lot. Yeah. But concluding things about an integrated system on it is a really, really difficult thing to do. If you compared that to things like the McLaren Vehicle Dynamics Simulator, yeah, with the amount of power that has behind it and the way that that has made sure you've got deterministic things around that. And that is why people pay for that as a simulator, because it reduces their time to market by 3 years.
Mm.
Yeah. And you can lay a thing. Carla, on the other hand, is sort of sitting on the side there. And one of the things that was observed was even when you bingo some of the deterministic things, so a replay thing on that, if you're above about a 2%, it doesn't actually get you the same result twice, because it wasn't actually valued by the Unreal Engine that was sitting underneath it or whatever it is. Yeah, so because the games industry doesn't value determinism. But if I'm doing verification, yeah, the fact I can't actually prove I fixed it or can't do it a second time is a really big problem. So in your terms, in accountability and things of that nature, it seems to me you need to think carefully about some of those things. It's not that there aren't answers, but they are not just points of detail when you're doing simulations. So
yeah, we probably can't afford to pay Formula One prices for a simulator. So is there something else that you would recommend?
I wasn't suggesting that. I was merely suggesting that absolutely understanding those limitations and where you make out around them and the stuff that fits around that. Because otherwise it appears that you're saying something that that the tool undermines the quality of the research that you're doing.
Mm-hmm. No, I just wondered if there was something better that you could recommend that would be within our price range.
So people tend to do that by doing much more limited sets of things that allow them to incorporate, as you were saying there, the physical components and things of that nature in there.
Mm-hmm.
Yeah, and understanding elements that they want to do that. So it's that aspect of making sure that you can pull it together properly. Carla's lovely because it shows you all these pictures of what's happening in the world. But what you always forget is the system that failed is the bit underneath.
Mm-hmm. By the way, Craig, I owe you an apology because I said I thought your work was currently being done with Carla this morning, and that was my misunderstanding. I don't know what simulation you're using.
Oh yeah, so for the manipulation things, it's a Copelia sim is the name of it. It's a sort of robotic arm simulator. Very similar sort of setup actually, but just different application domain.
I thought you'd done an amazing job of converting Carla to deal with robot arms. But, my respect for you went up. So. Okay, so something from Stuart. Do you see simulations of the operational environment as an integration point for different sorts of expertise? I guess that simulations all have components that capture particular aspects of the environment. So it may be that the simulator has better characterization of the operational environment than any single expert. I guess the integration of different simulation components may raise many issues that are important to resolve. So, I think you could probably have more complexity in the simulation than any expert could handle. So that's certainly one aspect of that.
I actually sort of responded to this in the chat, so let me interject here.
Sure, yeah.
So I agree. You could have a multi-party conversation with the simulation, and actually natural language can really help facilitate that because all the various experts would want to understand what the other experts are saying. So you could conceive of it as a multi-party conversation with the simulation. So that they all input their expertise. But actually, even if it's only a single user, the model I have in mind is that that user becomes more expert at predicting what the behaviors are going to be and where failure will happen. And through their expertise, hopefully they have it, they can change the spec and the environment to avoid those failures and actually test whether the changes they've made do indeed avoid the failures through simulation. So in other words, a single user can learn more and become more expert by interacting with the simulation environment.
Is that true because we're dealing with toy domains, or would it scale up?
No, I think it's extra true when the domain is complex because people are really, really bad at recall in a complex thing, right? Things will just be off their radar, like, oh, I didn't think that lightning might strike here, right? That's I was just like, it was like not yet, I didn't even consider it. Oops, I better do something about that contingency, right? So people just aren't very good at thinking and reasoning about every single contingency. Oops, that's my phone. I'll mute myself.
Okay, well, let's shut Alex up for now. Maybe move on. Andy, you sent this rather cryptic message. I guess it's associated with the screenshot that you sent us. Is that we have to look at the screenshot to see this interesting contrast between human oversight and explanation?
It is, Alan. Yeah, you have to look at the screenshot is Article 15 of the EU Act.
All right, okay.
Which is about human oversight, and that's what the law is requiring. Yeah,
Right.
It's really interesting when we get there's a very strong contrast between, technical discussions of explanation and human oversight.
Yes.
They're miles apart.
Mhm.
They're not at all, aligned, and I think that's deeply problematic. I think that's something we should be considering here.
But oversight, does that imply control, that you're in charge of it, and not just?
What does it say? What's the requirement? I mean, it's like people said, I'm sure it's going to change somewhat, but if you look at the requirement, then it's.
Yeah, to me, oversight would imply that you're somehow managing the process.
Oh yeah, you're in charge of the machine, including being able to override it, including being able to interrupt it and stop it entirely.
Yes. Yes.
Yeah. It's not oversight in a general governance sense. For example, accountability. It's hands-on oversight.
That seems to me to pose really, really tough problems for machine learning systems. I mean, they don't allow that kind of dialogue. Within a simulation, that might be a little different because you can impose constraints or relax constraints in order to change the simulation. But
I think it's massively challenging. Absolutely.
Yeah.
When you kind of the kind of thing you've taught, for example, like Lime and those kinds of methods, they don't give you the kind of things that have been described or outlined in the regulation.
Mm-hmm.
But there's a world apart, and that's where we're at. I think at the moment, there's just a world apart between technical discussions of explanation and how things get going down a technical rabbit hole around these things, and then what the law requires. And even with GDPR, which I think Chris mentioned earlier, the right to explanation was a right to explanation from a human being.
Yes.
The right to explanation from a person. So the fundamental challenges are how we get to grip with explanation and how we get to grips with it in the ways that the legislation is anticipating, particularly the AI Act. I think is some work, certainly me and Lachlan have been talking about it. It's certainly work that needs doing just to start to open up what the challenges are here as well. They're not straightforward. It's not clear. But challenging all around.
It may depend the level of explanation that you required. So if it's sufficiently abstract, you can treat each machine learning system that's a component in the system as a black box. So you could give an explanation, the Tesla car bumped into this ambulance because it didn't see it. That's perhaps not very helpful, but that is a high level explanation. It doesn't explain what went on inside the machine learning system that meant it failed to see the ambulance. Yeah.
I understand, and yes, and those kind of debates have been going on for a while as well, I think, haven't they? Mm. Along with counterfactuals and things like that. But there's other people want to talk. Their hands are up.
All right, okay, let's move over to some questions, Lachlan.
It was just to pick up on Andy's point there as well around how it seems to go beyond explanation. You look at the provisions of this particular article, and it talks about even being able to intervene in an operation or interrupt it through a stop button or similar procedure, or so it's very much going beyond just trying to explain what's going on and giving that degree of agency to the person who has that oversight to actually do something about the system if it's behaving in a way that it shouldn't be. So I do wonder how far that goes beyond a lot of the explainable AI kind of work. So
how useful that is dependent on how time critical it is. So it's all very well being told, yes, you can steer the car now if you're 2 seconds away from a crash.
Yeah, definitely. So I think that there's a lot of stuff in there that we could think about and how we could sort of move beyond some of the current approaches. So it's a really interesting provision.
Ram, you wanted to come in.
Yeah, I wanted to just observe that. I mean, so some of these are big questions, so it's good that they're coming up. So the way I see it, there's many facets to this gap. But the first thing I wanted to say is that we don't have to solve the full problem in this node. We have to make progress towards solving it. And so it is good that we have all of these perspectives and we're trying to push them towards each other. But the other observation I have about explainability is I think of that as just one piece of the puzzle. So in reality, explainability in the sense of Lyman Sharp may have not so much to do with the oversight, and actually understanding error rates or performance characteristics may have more. That's why we're kind of exploring both of these. And the example that my machine learning colleagues often give is, if I ask a physician to tell me how an EEG machine works, then it falls apart pretty quickly. I mean, their understanding of electronics is extremely rudimentary, and it falls apart beyond what's on the screen. And yet they feel like they have oversight over it, and they feel comfortable. And in some sense, it may be a similar situation with AI systems as well. I mean, you're going to have a kind of high level performance characteristics, empirical statistics level understanding, and oversight may be built on top of that. But if we ask the medical system, does anybody understand the EEG machine? Then the answer is yes, somebody in the system understands it. And there's been this chain of somebody understands it, they give empirical statistics, and somebody else trusts it. And so that setup may be how it ends up happening, I think. And so it's not that any one of these technical tools is the full answer to any of the legal questions. It's more that they have to be pieced together. And ultimately, it will be a product. So the oversight is over the product, and the technical pieces are what we are giving to the product designer to put together to make the whole thing, I think.
Mm-hmm. Right. Should we go back to these chats? So the next one from Peter was another criticism of Carla, saying it's not allowed to replicate or replay results. So you can't prove that you fixed the problem. Do you want to elaborate on that, Peter? I'm not quite sure why you.
I think we covered that on the previous one. It's not Carla itself that's the problem there. It's the engines underneath that you've got that are not necessarily managing to do that. And if you look, a lot of the game-based things, the reason we use supercomputers, was part of a study that we did that analyzed what was the difference between things that got their resources. So when you hit the physics, you increase your requirement, and then you get to a situation where resource has to be delivered to do this. If it's delivered in a non-deterministic way, and even on a single PC, that tends to be true. So if you're looking at a multi-threaded thing between processors on a single PC, all you need is an exception there. I think the study they did down at Bristol, or the paper they wrote, it was about 2% utilization that you get into variability in the way that, so you get non-determinism, and you can bingo the box that says, I want to be able to replay the result. It just doesn't.
I see.
Yeah.
So is this is not a matter of degree then? You're not saying that it will vary slightly between replays. You're saying that it will go down a dramatically different path.
Well, since we all know, it's Rice's theorem and things. Single bit errors, relate to completely different outcomes.
Okay.
Yeah, and I'm not saying that makes it useless to you. What I'm suggesting is you absolutely need to be on top of what all of those things mean when you're talking about explainability and things, because it's coming out with completely different results. And when we were doing this in the safety area, what we were discussing was, I can't get a 99.9999% thing out of this. I can only get 50% probability out of this. Those sorts of differences have dramatic impacts on what you might want to be able to take to court to say in relation to regulations. Yeah, and it's I'm just advocating that you need to make sure you understand that in what it is you're claiming and what the counter might be.
But the answer would perhaps be that you just make multiple runs of essentially the same setup, and then see what percentage of outcomes you get.
You didn't get anything like the same outcome. It just doesn't work that way.
But you might say, at some level of abstraction, you might get two different kinds of outcome, and you could say that 30% of the time this happens, 70% this happens.
Yeah, but how do you ever know you fixed it at that point? How do you ever know? In terms of your explainability, that has major.
Well, you would have to deal with both. You'd have to show that you
would have to deal with both implications. Yes. Yeah. So as I say, it's not that I'm saying it's rubbish. That's not what I mean in relation to that. What I mean though is those things are the tool. It's the same thing as I put a later question down, and I'm going to have to go now, which is why I'm going to raise it for you. Yeah. What does it mean when you're trying to give explainable AI on a perfectly functioning machine as opposed to one that is malfunctioning? That seems to me to be a difficult question in relation to that, because I'm doing my own poisoning attacks.
Yeah.
So I'm intrigued. The next comment comes from Bruce Edmonds, which is the same name as we got the spam from this morning. Is that right? Are you the same Bruce Edmonds? No answer. No,
So I
Bruce.
think what has happened, if I don't know if Bruce Edmonds is on the line, is that if I've understood correctly, he's a guest of one of our industrial partners, I think
Right.
HCL. And we hadn't realized this in the morning when we got all of those back and forth messages. So it was not a security issue as we thought it was. It was just somebody we didn't recognize.
I see. I mean, in my calendar, a completely different meeting was advertised by Bruce Edmonds, just right shifted from the one that we're at now. You didn't get that?
I haven't traced all of them.
Okay, well, yeah.
I got it, Alan, but inside there was the identical program to the one.
Yeah, it's the same program. It's shifted by an hour.
No, it wasn't time shifted. It was just the appointment was time shifted, but the actual agenda inside still started at 10. Yeah. So it looked a bit like finger trouble to me more than anything else.
Yeah, maybe he accidentally set it up and then cancelled it.
Yeah.
And then we thought the whole.
In any case, I think it sounds like it. I mean, I was a bit worried about system security from that point of view, but this sounds just like a miscommunication.
Okay, well, he hasn't spoken up, so I assume he's no longer here. So I'm not quite sure what to make of the question. So, and then Alex, this is you responding to Stuart, as you said. I think Alex is gone now.
Yes.
Oh yeah, no, there you are. Yeah. Okay, and then Alice. One of my colleagues has a real autonomous care to experiment with, not allowed to take it out of the road on the road though, so needs to use simulation. Oh, that went car, not care. Yes. I think Alice has gone. I read that as well. It says care, and I thought that was correct. I thought we were talking about healthcare situation. Yeah. So Burkhard says he's building a physical toy car in ASEC for this. May be able to share.
Not me. That's the David Espinel and the.
Right. Oh, this is the AI security group. Yeah.
I just know that is one of the things he is
right.
His RA is doing and experimenting with.
Yes. And yeah. And Peter, you said, have we considered explainable AI in a perfectly functional machine and explainable AI in a malfunctioning machine? Malfunctioning machine is the interesting case, right? I mean, if you're trying to explain why things went wrong. Anybody want to speak to this?
Well, I was actually thinking about the using these kind of large scale AV simulations in Carl and things. I think it's the AV case is quite a good one because you do have a pipeline of interlocking systems that might all be machine learning based. So you have a perception system that might go into a global planner for waypoints that goes into a local planner. And I like the idea that you might be able to say, well, what if one of those components malfunctions and introduce like noise that you understand for the perception system, but keep the controller perfect. So I think there's a kind of what if slot in, slot out thing that might be good for explaining these malfunctioning parts of like a larger system. So I can see simulation being useful in that.
Yeah. So in terms of providing an explanation at a high level, you could say which component of the system was malfunctioning, for instance. So you could say, well, this accident happened because the image recognition or the planning or whatever went wrong.
Yeah, you can also ask the reverse question, which is if you have some sort of robustness metric, you can say which parts is important do not go wrong so that the system functions. So you can do things like assume that your whole system is perfect, like an explainable system, and find that actually, if I come to an emergency stop behind a car that I didn't expect to stop at a traffic light, I only have a very small amount of robustness. So in those situations, it's very important that the obstacle detector works almost perfectly without noise, because any perturbation would mean that I failed that test. So I think it's good for asking that kind of reverse question as well.
this sort of assumes a smooth variation between the different of each system in its behavior. If there's sort of radical jumps in the behavior, then it becomes more difficult. Lachlan, you posted something about Article 14. Do you want to just take us through that?
It was just a follow on with the discussion we'd had, just a bit more detail as to the specific elements.
Oh, right, the human oversight versus explanation. Yeah.
Yeah, it was just that. But so don't need to go into it further.
Okay, well then all these messages say that people are leaving. So I think we're probably coming to an end, Ram. Shall I hand back to you?
Yeah. I think I don't have too much more to say except thank you to everybody who put together the presentations. I mean, it was a long day and a lot of preparation, but I thought the conversation was extremely useful. I've noted down several big questions, a few small questions. These are definitely things we should all be following up on. In the immediate kind of things, Suzanne has recorded these. She'll put them up on the YouTube channel, share it with people. All the speakers who had slides, please put it in, please share it with Suzanne so we can put it in one place and share it with the group. And then for the management board, we'll organize the IAB and SAB separately as we've been discussing. And I think that's everything. And of course, I should say thank you to Suzanne for helping corral everybody, put things together and organize today.
Okay, thanks very much.
Thank you.